Welcome, space enthusiasts, to another thrilling episode where we unravel the mysteries of the cosmos. Today, we're embarking on a journey through time to explore one of the most groundbreaking shifts in human understanding, the heliocentric model of the universe. Buckle up as we travel from ancient Greece to the Renaissance and beyond to uncover how our view of the universe transformed dramatically over the centuries. Imagine a time when the Earth was believed to be the center of the universe, with the Sun and all other celestial bodies revolving around it. This geocentric view, championed by ancient scholars like Aristotle and Ptolemy, dominated our understanding for millennia. The stars, planets, and even the Sun were thought to orbit our seemingly stationary planet in perfect circles. This idea was deeply entrenched in the philosophies and scientific theories of the time. Aristotle, the renowned Greek philosopher and scientist, proposed that the Earth was the immovable center of the universe. His ideas were later formalized by Claudius Ptolemy in the 2nd century CE. Ptolemy's work, the Almagest, became the cornerstone of astronomical knowledge for centuries. He introduced the concept of epicycles, small circular motions within larger circular orbits, to explain the observed movements of the planets, which occasionally appeared to move backward in the sky. But as time went on, the geocentric model faced increasing scrutiny. By the late Middle Ages, scholars and astronomers began to notice discrepancies and inconsistencies in Ptolemy's model. The complex system of epicycles, deferents, and equants became increasingly unwieldy, raising more questions than it answered. Enter Nicolaus Copernicus, a Renaissance polymath whose revolutionary ideas would forever change our understanding of the universe. Born in 1473 in Torun, Poland, Copernicus was not just an astronomer, but also a mathematician, physician, and cleric. His wide-ranging interests and talents positioned him perfectly to challenge the prevailing geocentric paradigm. Copernicus proposed a radical shift, the heliocentric model. In this model, the Earth and the planets revolved around the Sun, not the other way around. This wasn't just a new theory, it was a revolutionary idea that resolved many of the inconsistencies plaguing the geocentric model. Copernicus's heliocentric model simplified our understanding of the cosmos. It explained the apparent retrograde motion of planets like Mars and Jupiter, which had puzzled astronomers for centuries. By placing the Sun at the center, Copernicus showed that these planets' strange movements were due to the Earth's own motion. However, Copernicus wasn't the first to suggest a sun-centered universe. Ancient astronomers like Aristarchus of Samos had similar ideas. Aristarchus, a Greek astronomer from the 3rd century BCE, proposed that the Earth orbited the Sun. Unfortunately, his ideas didn't gain much traction at the time, largely overshadowed by the dominant geocentric views of Aristotle and Ptolemy. Copernicus's heliocentric model was also influenced by the works of Islamic astronomers during the Middle Ages. Scholars like al-Biruni and al-Tusi made significant contributions to astronomical knowledge, questioning, and refining Ptolemaic models. The Moraga school, in particular, was known for its advancements in observational astronomy and mathematical techniques. By the early 16th century, Copernicus began to circulate his ideas among his close friends and colleagues. He summarized his heliocentric hypothesis in a short treatise titled Commentariolus, or Little Commentary. This manuscript outlined his revolutionary ideas in 7 general principles. These principles stated that celestial bodies do not all revolve around a single point. The center of Earth is the center of the lunar sphere, the orbit of the Moon around Earth, and all the spheres rotate around the Sun, which is near the center of the universe. Copernicus's ideas were groundbreaking, but he knew they would face significant opposition. At the time, the Catholic Church held great influence over scientific thought, and any challenge to the geocentric model could be seen as heretical. Copernicus was cautious, withholding the full publication of his theories until he was near death. In 1543, his magnum opus, De Revolutionibus Orbium Coelestium, or On the Revolutions of the Heavenly Spheres, was published. This work detailed his heliocentric model with rigorous mathematical proofs and observations. The impact of Copernicus's work was profound, but acceptance was slow. the heliocentric model faced considerable resistance, particularly from religious authorities. However, within a few generations, the scientific community began to embrace this new understanding of the cosmos. The heliocentric model gained influential supporters who further refined and validated Copernicus's ideas. One of the most notable of these supporters was Galileo Galilei. Born in 1564, Galileo is often regarded as the father of observational astronomy. He made significant advancements using the telescope, a relatively new invention at the time. Galileo's observations provided compelling evidence for the heliocentric model. He discovered the 4 largest moons of Jupiter, now known as the Galilean moons, proving that not all celestial bodies orbited the Earth. He also observed the phases of Venus, which were consistent with the heliocentric model but inexplicable under the geocentric system. Galileo's advocacy of the heliocentric model brought him into conflict with the Catholic Church. In 1633, he was tried by the Roman Inquisition and found guilty of heresy. He was forced to recant his views and spent the rest of his life under house arrest. Despite this, Galileo's work continued to influence future generations of scientists. Another key figure in the acceptance of the heliocentric model was Johannes Kepler. Born in 1571, Kepler was a German mathematician and astronomer who is best known for his laws of planetary motion. Kepler built on Copernicus's heliocentric model by introducing the concept of elliptical orbits. Before Kepler, it was believed that planets moved in perfect circles. Kepler's meticulous observations and calculations showed that planetary orbits were actually elliptical, with the Sun at one focus of the ellipse. Kepler's laws of planetary motion, describing how planets orbit the Sun in elliptical paths with varying speeds, were a significant breakthrough. They provided a more accurate and predictive model of the solar system, resolving many of the discrepancies that had plagued both the geocentric and early heliocentric models. The heliocentric model's acceptance was further solidified by the work of Sir Isaac Newton. Born in 1643, Newton is one of the most influential scientists in history. His work in physics and mathematics laid the foundation for classical mechanics and modern astronomy. Newton's law of universal gravitation explained the forces that govern the motion of celestial bodies. He showed that the same force that caused objects to fall to the ground, gravity, also governed the motion of the planets. Newton's Principia, published in 1687, provided the mathematical framework to describe the motion of the planets around the Sun. His laws of motion and universal gravitation were instrumental in transforming the heliocentric model from a hypothesis into a robust scientific theory. The impact of Newton's work was profound, cementing the heliocentric model as the accepted view of the cosmos. As we reflect on the journey from the geocentric to the heliocentric model, it's clear that this transformation was more than just a scientific revolution. It was a fundamental shift in how humanity perceived its place in the universe. The heliocentric model challenged deeply held beliefs and demonstrated the power of observation, mathematics, and critical thinking in advancing our understanding of the natural world. Today, our knowledge of the cosmos continues to expand. The heliocentric model laid the groundwork for future discoveries and explorations. With the advent of powerful telescopes, space probes, and advanced computational models, we have uncovered new layers of complexity in our solar system and beyond. From the discovery of exoplanets orbiting distant stars to the intricate dance of galaxies in the vastness of space, our journey of discovery is far from over. So, what does the future hold for our understanding of the universe? As we continue to push the boundaries of scientific knowledge, we must remain open to new ideas and willing to question established paradigms. The story of the heliocentric model reminds us that science is a dynamic and ever-evolving process, driven by curiosity and the pursuit of truth. We hope you enjoyed this deep dive into the history and impact of the heliocentric model of the universe. It's a story of bold ideas, relentless inquiry, and the triumph of human ingenuity. As we look up at the stars, let us be inspired by the legacy of those who dared to question the status quo and forever changed our understanding of the cosmos. Thank you for joining us on this cosmic journey. Don't forget to like, subscribe, and hit the bell icon for more exciting explorations of the universe. And as always, stay curious and keep asking those big questions. Until next time, keep looking up.